Today's flight computer video is on the Aircraft Navigational Computer Mark 8. This is the design, the sort of ultimate design of what we call the front face of a flight computer. It is the design that is used on every flight computer that is still manufactured today. It comes from Philip Dalton in 1933 or thereabouts. Now, you may say, I don't see Philip Dalton's name anywhere on this device, and I don't see a date anywhere on this device. And it's true. We've got to work our way backwards in order to figure this out. So we can start in 1936. In 1936, we had Dalton's Model G dead reckoning computer. The patent again was 1936, and if we look at the front face of this computer, it has identical functionality as the Mark 8. If we move ahead one year, we have the Dalton Aerial Dead Reckoning Slide Rule Model B, which has a copyright on it of 1935. And the device itself, this Mark 7 flight computer, comes from 1934, copyrighted 1934. And this slide rule is a little bit more detailed than the Mark 8, which suggests that the Mark 8 came before it. And perhaps the ultimate clue is that other flight computers of this era that use a similar design can be found that have a copyright of Philip Dalton 1933. We know that Philip Dalton enlisted in the US Navy in 1931, and it seems that between 1931 and 1933, he came up with this very elegant design for a flight computer. In order to understand why it's so elegant, though, we have to sort of compare it to other things that were around at the time. So here's a general purpose circular slide rule from 1936. You can tell that the numbers go from 1.1 and wrap around to 9, and the calculations are done by moving these two cursors on the device. It's very busy, it has lots of scales, front and back side, whereas Dalton's design is very simple. It has three things that really matter for us: miles, minutes, and a speed index at the number 60. Now, many of you know that these scales are wraparound scales. So this 60 miles could actually be 6 miles, or it could be 600 miles. It doesn't matter because it's a circular scale. Whereas on other flight computers of the time, such as this one, which is from the early 1940s, we don't have that wraparound. We don't have that even placement of the scale around the circle. You can tell that this flight computer goes from 10 minutes up to 8 hours, and from distances from 18 up to 1,000, but there's no clear wraparound. And perhaps these flight computers were trying to work around the copyright of Philip Dalton in 1933. Okay, let's put this to use. We're gonna put it to use with a very, very simple problem, perhaps the simplest problem of all, but we're gonna look at the magic that's behind it. So let's give ourselves a ground speed of 90 nautical miles per hour and a distance to fly of 36 nautical miles. And the question is, how much time is that going to take? Now, we'll just do the answer on the Dalton flight computer here, and then we'll look at the magic that's behind it. So we know, we just take the speed index and we put that on our speed here of 90 nautical miles per hour. And then we go and we find our distance on the mile scale, 36 right here, and we move in and we read minutes on the minute scale. It's gonna take us 24 minutes. That's gonna take 24 minutes. And something magical actually just happened there, and it may not be evident. Even if you've been using one of these your whole career, you may not realize this amazing thing that happened. So let's walk through the magic of this. We have a very simple formula here, which is that time equals distance. And I'm going to put our distance here in nautical miles, since that's what we just did, divided by our rate. And our rate here was in nautical miles per hour. That's the formula. It's one division. It's not a big deal, right? Or is it? Well, let's go ahead and punch in those numbers. So what did that actually look like? Time equals 36 nautical miles divided by 90 nautical miles per hour. And so when we look at our units here, the nautical miles will cancel out and it will give us our answer of 0.4 hours. Wait a minute, this is not how we look at our clocks. The answer in hours doesn't really help us. And when we got our answer on the Dalton computer, we got it in minutes. So how did that work? Well, most of you know how to convert hours into minutes, that we have 60 minutes in an hour, but let's walk through this problem again and really think about what's going on with the unit. So what we actually do here on the Dalton flight computer is we have our time equals our distance, and our distance is in, again, nautical miles. Could be in statute miles, wouldn't make a difference. And our rate is still going to be in nautical miles per hour, but what we want is our rate in nautical miles per minute, because we want an answer in minutes. So we would then have to divide our rate by 60 minutes in an hour. And a nicer way to write this formula, rather than thinking of it as these two divisions, would be to take the entire denominator and multiply the top, the numerator, by the reciprocal of this. And that actually it looks pretty nice when we do it. So we'd end up with time equals distance times 60 minutes per hour divided by our rate in units per hour. So in this case, we're going to say nautical miles per hour. So this is what we're actually doing here. This is what the Dalton flight computer does for us. And it's very clear when you break that down. Oh yeah, we start with a division. So we had 60 minutes, which is right here, and we divided 60 by 90. That's the first thing we did. That's why we set the 60 to the 90. And the next thing we did was multiply by the distance. And then we multiply all the way over here by 36, and we get our answer of 24. And so again, just to make everything clear and to write that out, how that all works, we bring this down. Our distance is 36 nautical miles times 60, again, minutes per hour divided by 90 nautical miles per hour. Cancel out the hours. We end up with minutes per nautical mile. Or if we want to write that again, 36 nautical miles times 0.66, repeating, nautical miles per minute. And that gives us our answer of 24 minutes. So it may seem like a simple little device, but if you're wondering what's actually happening, it's more than just distance divided by rate. It's actually distance divided by rate divided by 60, so that we get our answers in something that we can use immediately, which is a number of minutes, which we can apply to the clock. Okay, so that's it for the Dalton Mark 8. Clearly, the thing that's missing here is a way to solve for wind problems. And so what we see is that the Mark 8 in its next evolution comes back on the Mark 3 plotting board. This is a giant board that pilots had to carry with them on the flight deck. You can see another copy of the Mark 8 here. We'll look at some wind problems on the Mark 3 plotting board in the next video. The thing that happened after that Mark 3 plotting board was it started to shrink down. And so then it did shrink down into the Mark 7 flight computer, which is quite a bit smaller. And then the Mark 7 flight computer shrunk down into the Model G with its very cool endless moving belt. So if you're interested in solving some of those wind problems, check out the next video, and thanks for watching.